here is beta decay. Alright, I draw another line here since I went too far. I've gone too far, yet again. Okay, so beta is a little different. Here's a beta decay. Oh God, no. Beta is both simpler and more complicated. Oh, no, don't freeze on me now. Oh, sorry. Okay, so in a beta particle emission, irritatingly, this doesn't show, but what comes out is just an electron. An electron comes flying out of a beta decay. And the thing is, this is what we have to do. In order to understand that, we have to go back to what I told you before about what a neutron is made of. What's a neutron made of? A neutron is made of a proton and an electron living together, cohabitating. And sometimes, no matter how hard they try, the proton and the electron, they go their separate ways. And what happens when that happens in the nucleus of an atom is that the neutron loses the electron, and what's left? Just a proton. And so that's what happens. The electron's like, I can't take this anymore. And the neutron's like, no, baby, come back. But then it's just a proton. Because don't forget, it was a proton. And I'm sorry, that's maybe not appropriate. It happens to the best of us. But again, when the electron leaves, it's no longer a neutral proton and electron together. The electron's gone, it's just the proton. And that's what's left, neutron, then proton after the electron leaves. And so that's what a beta decay is when a neutron deep within the atom breaks up. And so, which makes it a little more weird, but once you get the hang of it, we can even start with what we ended with last time, because thorium-234 undergoes beta decay. Actually, thorium-234 spits out an electron. Let's make it green, or a beta particle, and what you're left with is something that has not changed its mass at all, because, well, you have one less neutron, but you have one more proton, so it's like nothing really changes as far as the mass. It's still 234, but somehow it's a different substance, and that's what we have to get into. And this is the last thing, so please remember that. Well, it's the last hard thing. So let's do the same. I'm going to erase this one for now so that it's not taking up your visual and mental space. So you got your thorium-234, right? That means it has 234 protons plus neutrons, and you might recall it has 90 protons. Okay? And don't forget that one of those neutrons lost its electron, so it started out as a neutron, lost its electron, that's this electron, and became a proton. So this number stays the same, first of all, because it lost one of these but gained one of these. So this number stays the same. But this number doesn't stay the same. This number, 90, basically, plus 1, gives us 91. So now it has 91 protons because a neutron became a proton. So it has 91 protons. Let me draw that better. 91. And so that means all we have to do is go to our periodic table, find number 91, and we see that it is Pa. Uh-oh, I didn't do that right. Pa. protactinium, for those of you playing our game at home. But really, just PA is fine. Don't worry about the name. It's one of the weirder chemical names. Okay, so the last thing is, what do you write for a beta particle? It really depends, but usually people can write different things as far as what they write here. You could write beta, and the numbers you write here are 0, since there's no protons and no neutrons in it. And this is the weird thing that some people have a hard time with. You write -1 because it's an electron, and because, since you're subtracting it, 90 minus -1, which, don't forget, 2 minuses makes positive, equals 91. I know that's not very satisfying, but it's the way it is. Just think about it this way. If it goes, whoops, I'm almost done. If something goes from 238 to 234 and it loses basically 4 from its mass and loses 2, then that's always an alpha decay. He. If it doesn't change its mass and it gains an electron, or it gains a proton, that's beta. And then gamma is really simple. Okay? I promised you gamma would be simple. Gamma is very simple. Gamma is just a wave of energy. Gamma isn't a particle at all. Gamma is just energy. And so, if you have, let's say, americium 200, and it spits out a gamma ray, it's still going to be the same thing when it's done. It doesn't lose any protons, it doesn't lose any neutrons, it doesn't lose anything. Am I moving too fast? Can I erase this? Can I erase this? That's my question. I can erase this? Okay. This will be posted to the internet later on. So, americium 200 over 99 shoots out a wave of light energy, or it's not light energy, it's electromagnetic radiation, which is also known as 0, 0, gamma, because there's no protons or neutrons in it, and so it's 0, 0 plus the same thing you started with. So that's it. So that's gamma. Gamma is very simple. When you see this on a test, it's either going to lose 4, which makes it alpha. It's going to gain 1 proton, which makes it beta, or nothing's going to change, which makes it gamma. It's not so bad as all that. Okay, thank you very much for your excellent attention today. I appreciate it. I would like to have those worksheets, please, under the Kleenex box where the other worksheets are. Thank you very much. Enjoy your day.